Hello students, welcome to this 8th lecture of the kinetic theory of the gases and the radiation. So in this lecture we will see the next part of this chapter, but before that what we have discussed in the previous lecture we will see now. So in the last lecture we have discussed about the Kirchhoff's law of heat radiation, and after that we have covered the part of the spectral distribution of the black body radiation, and we have seen its a graphical representation also with respect to the wavelength, and we have seen the 6 facts or the 6 observations that has been concluded by the scientists. Now students, we will now proceed the next part of this video. Now students, the next part we will discussing is Wend's displacement law. So first of all we will see its means what the concept they have given, what the on which factor that the Wend's displacement law will be dependent, we will see. Then we will just see the mathematical representation and the standard values. So the Wend's displacement law, it's observed that the wavelength for which emissive power of the black body is maximum is inversely proportional to the absolute temperature of the black body. This is Wend's displacement law. Means what he has stated in this law we will just see again. The wavelength for which the emissive power of the black body is maximum, means there will be the lambda max, is inversely proportional to the absolute temperature of the black body. Means students, if we have to just represent this mathematically, so we can write that is lambda max. So that is which has been given in the law as the wavelength for which emissive power of the black body is maximum. That will be the term lambda max. So lambda max is inversely proportional to the 1 by T. Your T is nothing but the absolute temperature of the black body. Absolute temperature of the black body, and this is nothing but that is lambda max is directly proportional to the 1 by T, is nothing but the Wend's displacement law. Or you can write this law in term, if we have to just remove the proportionality sign, then lambda max is equal to B by T. So if we just rearrange this equation given by the Wend's displacement law, then lambda max into T is equal to B. So we will just understand what mean by the lambda. So you have know that what mean by the lambda max. The lambda max is the wavelength for which the emissive power of the black body is maximum. That is your lambda max, and your B is called the Wend's constant. Wend's constant, and its a value is 2.897 into 10 to the power of minus 3 meter Kelvin. So this is the law. Now the lambda max indicates the wavelength at which the body dominantly radiates. Dominantly means with a high extent, or with a high you can say with a high amount. That is the lambda max. Now thus it corresponds to the dominant color of the radiating body, and it is the function of temperature. Means we can say that the dominant color corresponds to the dominant color, means there will be the high intensity of color at that lambda max extent, means that emissive power, that the emissive power of lambda max will be extent. So color will be too much of a higher content, or you can say higher extent of the radiating body, and it is the function of its temperature. Now we have heard of white dwarf and the red giants. White dwarf are hot star, and the surface temperature is nearly equal to the 10,000 Kelvin, and the white red giants are cooler, correspond to the surface temperature nearly equal to the 3000 Kelvin. So this was all about the Wend's displacement law. Now students, we will just revise one more time this law for your better understanding. Now in the law they have stated that the wavelength for which the emissive power of the black body, the wavelength for which emissive power of the black body is maximum is inversely proportional to the absolute temperature of the black body, and this is our Wend's displacement law. So if this law we have to just represent mathematically, so we can write lambda max is inversely proportional to the 1 by t, and this may be also written as the lambda max is equal to b by t. And if we rearrange this equation, then this will be termed as the lambda max into t is equal to b. Now we will just understand what mean by the lambda max, t and the b. So as we know that the lambda max is the wavelength for which emissive power of the black body is maximum. Lambda max is nothing but a particular wavelength for which emissive power of the black body is maximum. And that of b is called as a Wend's constant, and its a value is b is nothing but the Wend's constant, and its a universal standard value is 2.897 into 10 to the power of minus 3 meter Kelvin. So this is the b and value of b. So student, if you have asked the example for the NEET and JEE, then you have to just able to write this value of b. They may ask you the value of b, or they may ask you the absolute temperature T, or they may be ask you the value, the wavelength of that black body having the maximum emissive power. So if any one term you will be asking in the exam, then you will have to, and the value of b may not be given sometime, so you have to just know this value of b, which is 2.897 into 10 to the power of minus 3 meter Kelvin. So this is the value you have to keep in your mind, or this value may be directly asked for the questions, that you may be asked like that the you can say the value of Wend's constant b is, and you will be having the 4 options. So you will have to select the correct value, which is 2.897 into 10 to the power of minus 3 meter Kelvin. And one more important thing you have to keep in mind is they may be give some variations in the units. So here the correct and the accurate unit is meter Kelvin. You can see here they may ask you the meter in degree Celsius, they may ask you in kilometer in Kelvin. So these may be the few variations that you may face into your exam. So you have to keep in mind in the very precise way. So the accurate value is 2.897 into 10 to the power of minus 3 meter Kelvin. So the lambda max indicates the wavelength at which the black body dominantly radiates. Dominantly means at very high extent. So it corresponds to the dominant color. So as the black body will be dominantly radiate, so it will be corresponding to the high intensity color. Okay, so radiating body and its a function is temperature, means as the temperature will be increasing, the body, that black body will be radiating more. As the temperature will be decreasing, the extent of radiation will be of that particular black body will be decreased. So this is how we can say that it is the function of its temperature. Now we have heard that the white dwarfs and the red giants. So this is, white dwarfs are the hot stars with the surface temperature nearly equal to the 10,000 K, and while the red giants having the corresponds to the surface temperature nearly equal to the 3000 Kelvin. So these may be also ask you for your exam. So this value, this standard value, you have to keep in your mind. Whenever in the exam the values will be asked, you will be able to recall that very easily, and in order to select the correct option and to get the marks very easily. So now we will proceed the next part of this chapter. Now students, the next part we have to discuss is Stephen Boltzmann's law of radiation. So what they have given in this law, it's a history part, and it's a which scientists have given anticipation about this law, we will see now. Now we have already discussed about the temperature dependence of the thermal radiation emitted per unit time by black body. So it is the temperature dependence. As the temperature will increase, the thermal radiation will also emit at the high extent or dominantly, as we have seen. And as that extent of temperature will be decreasing, the thermal radiation will be, its extent will be in that level. So in 1879, Joseph Stephen proposed an empirical relation between the rate at which heat is radiated from unit area of a perfect black body and its temperature T. So this sometimes this scientist may be asked for your exams. So this one also you have to keep in your mind. So he has proposed one empirical relation. Now empirical relation means it is the fixed values given into the mathematical form, from which you may ask to calculate different terms. So that is the empirical relations in between the rate at which heat is radiated from the unit area of perfect black body and its temperature T, which will be based on the experimental observations. And after exactly 5 years later, the Boltzmann derived the relation using the thermodynamics. Hence, it is known as the Stephen-Boltzmann law. So what the law he has stated, we will see now. So the Stephen-Boltzmann law states that the rate of emission of radiant energy per unit area, or the power radiated per unit area of a perfect black body, is directly proportional to the fourth power of its absolute temperature. Means we will just revise once again. The power radiated per unit area of a perfect black body, the power radiated per unit area of a perfect black body is directly proportional to the fourth power of its absolute temperature. So students, if we have to just rewrite mathematically, so we can write it as R is directly proportional to the T raised to 4. Means as they have told, the emissive power of the perfect black body is directly proportional to the fourth power of the absolute temperature. So we can write R is directly proportional to the fourth power of the absolute temperature. Or you can write in a way, if we have to just remove the proportionality sign, then you have to add some constant. So we will write as R is equal to sigma into T raised to 4. So where the sigma is the Stephen-Boltzmann constant and is equal to the value of sigma is 5.67 into 10 raised to minus 8 joule meter raised to minus 2, and the second raised to minus 1, and the Kelvin raised to minus 4, or simply Weber meter raised to minus 2 and the Kelvin raised to minus 4. So in this two way you can write its a unit, and its dimensions are, dimensions of sigma are length that the L raised to 0, M raised to 1, T raised to minus 3, and K raised to minus 4. So students, I would like to revise one thing, that the value of sigma you may ask in the exam. So they may give you in the form of second also, and in the form where the second will be absent. So this value you have to keep in mind. So the exact and the correct value is of sigma 5.67 into 10 to the power of minus 8 joule meter raised to minus 1. Means they may ask you joule per meter second Kelvin. This may be the first form. So this is you have to keep in your mind. And if you want to just take that term from the denominator into the numerator, then that entire term will be 5.67 into 10 to the power of minus 8 joule meter raised to minus 2 second raised to minus 1 Kelvin raised to minus 4. Or they may ask you in a way Weber meter raised to minus 2 Kelvin raised to minus 4, and it's a dimensions as you can see. So students, they may ask you that the meter, second, and the Kelvin may be in the option, that the terms, these terms may be in the denominator, and these terms sometimes may be asked in the numerator. If the terms will be in the numerator, then meter, second, and Kelvin will be having the negative powers, and if these terms are in the denominator, then the meter, second, and the Kelvin, these terms will having the positive power. So as it will be already in the denominator. And the next thing they will be asked you in terms of Weber meter raised to minus 2 Kelvin raised to minus 4. So exactly in the previous manner they may change the values and they may ask you into the exam. So this standard value you have to keep in your mind with the constant. It's a units. So this is what we have discussed in this video. So the next part of this chapter we will be discussing in the next video. Thank you so much.